Whoever invented the Stinger anti-aircraft missile is truly a madman. It is capable of sensing both the heat source and the profile of an airplane and adjusting its flight path in real time, so that no matter how sophisticated the pilot is, he cannot get out of the Stinger missile's lock, and it is truly impossible to escape. So how did he realize this function? The initial air defense missile is infrared guidance, can only rely on the heat of the aircraft engine to lock, and then explode in the vicinity. But this has a problem, that is, if the plane comes head-on, the missile is difficult to detect. To solve this problem, the Stinger anti-aircraft missile was born. Note that the Stinger anti-aircraft missile has a guide head that detects not only infrared light, but also ultraviolet light. We know that anything that generates heat emits infrared light, especially the engines of airplanes, and that's a target for the Stinger anti-aircraft missile. It even senses the flow of cooled air in front of it, so the missile can attack an airplane from any angle. Even if the airplane puts out heat flares, it's useless because the Stinger also has UV detection, which recognizes the outline of the airplane instead of the temperature. So the heat flare can only affect infrared rays, but is ineffective against UV rays. And the Stinger's guide head has high pixels to get a clearer image for tracking. The guide head is mounted on a gyroscope so that it can be moved over a wide area, so it can cover a larger area and can be accurately identified even if the aircraft makes a sharp turn. The aircraft data measured by the guide head is calculated in real time by the guidance component behind it, and the results are transmitted to the control component, which changes the flight path of the missile. Generally speaking, missiles have two pairs of movable wings, while the Stinger only has one pair that is movable, which reduces weight and makes it easier to carry. So how can you do omnidirectional tracking with only one pair of wings? Because the missile is rotatable, when moving the wings in the horizontal direction, it can control the up and down movement of the missile, while in the vertical direction it can control the left and right movement. Behind the wing is a set of batteries, and next to it is the warhead section, which can either explode immediately after hitting the target, or automatically explode 10 seconds or so after launch. Behind the warhead is the propulsion unit, which consists of two rockets. One is the launch rocket, which is used to push the missile out of the launch tube and to a safe distance, and the other is the missile motor, which is used to ignite and begin tracking the target. The launching mechanism of the Stinger air defense missile consists of the launch tube, the battery cryo module, the grip, and the all-important sights. Note that next to the top of the launch tube is an enemy identification antenna, which uses signals to determine whether the target is an enemy or friendly aircraft, avoiding the embarrassment of hitting yourself. Before firing, attach the enemy recognition to the grip, assemble the battery freeze film into the grip, and quickly deploy the enemy recognition antenna and aim the sights at the enemy plane. After pressing the enemy identification switch, you will hear an audible alert. If it is an intermittent sound, it is a friendly aircraft. If it is a continuous sound, it is an enemy aircraft. The enemy plane will appear in the side distance ring. If it is flying from left to right, position it in the left notch, from right to left, position it in the right notch, and from front to back, position it in the center notch. 10 to 65 degrees is the optimal launching angle. After aiming, the missile's guide head will be activated to detect infrared rays, and a beeping sound will be emitted when the target is captured. Finally, the missile's battery will be activated when the trigger is held down for more than 3 seconds. The missile's engine will burn for a while, then break through the disc of the launch tube, the wings will unfold and the launch rocket will separate, then the engine will start. The missile tracks the target at supersonic speeds and has a range of up to 3 kilometers, eventually pulverizing the enemy aircraft. Do you know that if the global conflict escalates, the United States, as the world's hegemon, may be destroyed? In response to this question, Russian experts have proposed a horrific battle plan, which is to use the king of nukes, Sarmat, to attack the Yellowstone volcano, thereby triggering a massive eruption of the 10,000-year-old volcano, which would completely destroy the entire United States. Once this plan was put forward, it immediately stirred up a huge wave of public opinion in the international community. So is this method really feasible? And what would be the consequences? First of all, the Yellowstone volcano, as the world's premier supervolcano group, according to relevant information, in the past 2 million years, has experienced 3 superlarge eruptions. Each can be described as destructive. Once the volcano erupted, the United States will cease to exist. So is it really possible for Sarmatian to hit the US and thus trigger an eruption? First of all, the United States has built the world's most comprehensive ballistic missile defense system, can intercept all kinds of ballistic missiles, currently divided into NMD and TMD, 2 major defense systems. TMD is known as the Theater Missile Defense System, is mainly used to protect the US outside of the theater of operations from attacks on near-range, intermediate range, or long-distance ballistic missiles. NMD is known as the National Missile Defense System, which is mainly used to protect the entire territory of the United States from any ballistic missile attack. It is the main defense of the United States. It consists of ground-based interceptor missiles, ground-based radars, space-based sensors, improved AWACS radars, and operational, management, command, and communication systems. Meanwhile, NMD is divided into two development directions, land-based and sea-based, namely, land-based mid-course interceptor system and sea-based high-level area defense system. As for the U.S. land-based mid-course missile defense system, its main combat target is the enemy's long-range ballistic missiles or intercontinental ballistic missiles. It can intercept the maximum range of more than 10,000 kilometers in the highest point of the ballistic path. The maximum speed of 24 times the speed of sound of the ICBM is the world's anti-missile combat capability of the strongest anti-missile system. As Russia's newest land-based ICBM, Sarmat is known as the King of Nukes, with a maximum speed of more than Mach 20, a maximum range of up to 18,000 kilometers, and the ability to carry 10 to 15 nuclear warheads, with an explosive yield of about 25 million tons. 25 million tons of what is the concept? When the United States to Hiroshima, Japan, dropped the Little Boy atomic bomb is 150,000 tons of TNT equivalent, which means that the Sarmat is equivalent to more than 1,600 Little Boy detonated at the same time, able to directly cover more than 500,000 square kilometers. The detonation of the Yellowstone volcano is no problem. However, American experts raised objections. They believe that Russia is not capable of implementing the program. First of all, from the geological level of analysis, U.S. experts believe that Russian experts are too high on the power of nuclear bombs. The Yellowstone volcano's magma layer is located in the ground at 8 kilometers. Even the strongest nuclear weapons, Tsarist hydrogen bombs detonated in the ground at a depth of 2 kilometers, cannot be affected at a depth of 8 kilometers. Sarmation, even scratching an itch, cannot be counted. So no matter how much the world is talking about, how panic, the United States has always believed that this plan is a fool's errand, simply not enough to fear. But there are people who suggest that if one Sarmat doesn't work, then use 2. If 2 don't work, then 10 or 100. You have to realize that Russia, as a super nuclear power, the last thing it needs in its hands is nuclear weapons. From an objective point of view, do you think this plan is likely to be realized? Do you know how offshore oil rigs come to extract oil? This equipment is the largest movable man-made structure in the world, and there are probably these types. Offshore oil rigs, being large structures, are used in areas of the seabed where the water is deeper than 500 meters to extract oil or gas from rocks. The platforms are made of large steel or concrete fixed to the seabed, but of course they can be fixed to the seabed at greater depths, up to nearly 1,500 meters. For deeper seabeds, floating oil rigs must be used. In this video we talk about semi-submersible floating oil platforms. These platforms are supported by large pontoons to provide buoyancy and can be towed from place to place, rather than remaining fixed in one location. Some oil rigs also have propellers under the pontoons to help move the platform, and when the towing is complete, multiple anchors at the bottom are used to secure it to the designated work site. The pontoon structure then sinks and is submerged by the sea. The pontoon is below grade with only the upper working platform exposed, so that most of the platform's mass is underwater, which could otherwise cause a catastrophe due to the constant swaying of the platform by the waves. Let's take a look at what's on top of the platform. This is the lifting system used to lift heavy loads and transport materials between the ship and the oil rig. The house next to it is the living quarters, where the crew lives and eats. There is also a helipad on the platform, where helicopters are used for emergency life-saving when necessary. These tanks on the top can be used to store water or fuel. And the torch chimney sticking out of the side is used to burn flammable gases, which, when extracted from the oil, contain gases, which have to be when gas is present in the extracted oil, it must be separated and burned off to prevent an explosion. Next we look at how an oil rig works. It is not easy to extract oil from the layers of rock that lie beneath the platform's deep seabed. First, the drill bit is lowered and a casing is placed over the drill bit so that the drill bit and casing are lowered together to the bottom of the seabed. When it touches the seabed, the drill bit starts drilling downward, and at the same time, pressurized water is synchronously pumped in, which pushes out all the dirt and sand. When the casing descends to a certain height, the casing will stop descending, leaving only the drill bit inside to continue downward. Once drilled to a certain depth, the crew will install smaller casing while cement is pumped into the casing and a plug is used to separate the cement from the mud. The plug is pushed downwards to ensure that the cement covers the outside of the casing and remains permanently in place, and this process is repeated when drilling deeper. As the hole is drilled closer to the oil reservoir, the casing becomes smaller and a device called a blowout preventer is installed. This is a very important step, as the blowout preventer is installed at the top of the wellhead to prevent any accidental high-pressure oil from spewing out of the formation, i.e., to prevent a potential blowout catastrophe. Let's take a look at the inner workings of a blowout preventer. The blowout preventer has two annular devices, which when tightened in an annular shape seal the oil below and prevent it from coming up, and multiple pressure seal welds underneath further prevent the oil from spewing out. These devices are topped with steel blades, and once the high-pressure oil enters the drill column, this ramp-like steel blade will contract and close, severing the drill column and sealing the well permanently. Once the oil has been successfully extracted from the seabed, it is continuously transported through oil pipelines above the seabed. Semi-submersible drilling rigs have the advantage of large working depth and flexible movement compared to jack-up drilling rigs, but they have large investment and high maintenance costs, require a set of complex underwater equipment, and have a lower effective utilization rate than jack-up drilling rigs.